Okay. So we have seen two compounds as artificial sweeteners. One is saccharin, the second one is aspartame. Now let us look at another molecule which is called sucralose. Sucralose, which is 600 times sweeter. It is 600 times sweeter than sucrose. All comparison is with sucrose only, that you should remember. And you can see the similarity in the name. That itself shows that it's a derivative of sugar. Okay. Now this substance is not absorbed. It is not absorbed into the blood, but simply excreted. It is not absorbed. This is one of the good advantage of any of the artificial sweetener, because you know the sweetness is the function of these compounds ends in the mouth. Sweetness is a feeling in the mouth, so you don't require this material to be absorbed into the bloodstream. Okay, so it is not. So once it is not any substance, it is not absorbed. It is a favorable condition. It is something good as far as the compound is concerned. It has to be excreted through the fetus or from the directly from the alimentary canal. Okay, so it is excreted and it is stable at cooking temperature. It is stable at cooking temperature. Now that you must already seen. Like you can use it in baked items. Okay, so it is generally used in salad dressings. And soft drinks. As I told you, it's a derivative of sugar molecule. So molecule is having this structure. We have an oxygen here. It is very similar to sugar. The difference is you have a CH2H. This is also there in sugar, CH2H. You have a chlorine over here. That is a structural peculiarity of the compound. Otherwise, you have the OH and H. Remember, all of these are H. The same configuration of that of sugar. It's a pi member thing. Because Furanose ring. Furanose. Pi member ring is called a Furanose ring. And here you have SCH2Cl. And one more CH2Cl here. Otherwise, you have other structures other than the alcohol or sugar. So it's here. So this is the structure of sucralose that is commonly used. Another one is additame, the last one which we have to discuss is additame, ALITAM, which is 2000 times sweeter. And again, this compound is also like aspartame. It's a amino acid derivative. So you have the structure like this, keto, a carboxylic acid group of an amino acid. This is of course CW1 NHCH3. So this part is adenine molecule NH, and here you have a four-member ring system with a sulfur on it. Two methyl groups here. Okay. So this is a dipeptide of aspartic acid and D-alanine. This part is aspartic acid. This part is part of aspartic acid. And this part is that of adenine. Okay. So this is an additional group which has the next two group of the molecule. Now, it is absorbed in the body. It is absorbed into the blood, but excreted through urine. Okay. After hydrolysis to aspartic acid. So absorbed in the blood and hydrolyzed to aspartic acid. Aspartic acid. And alanine amide. Okay, so this is getting cut. So remember here, this part is getting cut, and this part is also getting cut. So there is alanine amide. Oh, this one here. It forms amide means it's getting cut here. Okay. So right. And so that is the fate of the molecule once it is getting absorbed. And this molecule is used in many preparations. Food items. Okay. Now, so that is so these were the compounds which is generally used as sweeteners. I will take up a third class of compounds which are present in food. They are called antioxidants. Antioxidants. Antioxidants are they prevent the role is they prevent oxidative process. They prevent process. And thus they increase the shelf life, and thus they increase the shelf life. They increase the shelf life of the products. So that is a role. Now, what are the mechanisms? Okay. So what they do is they can do this by two methods. One is by scavenging the free radicals. Scavenge the free radicals. Free radicals goes. Most of the oxidation reactions, as you know, any of them, especially when it is in presence of light, they have a radical mechanism. So the free radicals will be generated in the system, the body. And these radicals will mainly act as catalyst for oxidation reactions. So if you scavenge them, scavenge means destroy. Okay. If you destroy them using this compound, the antioxidants, your food product will not be getting deteriorated. So that is a big idea behind this. The second one is, as we already mentioned, there are certain metal catalysts which are used, which are metal catalysts which are acting as, helping the oxidative process, the deterioration process. So what can be done is chelate the metals. That's a word being used, chelation, chelate the metal ions. Chelate the metal ions, acting as, this act as a catalyst for the which are bound to act as catalyst. Which are bound to act as catalyst in the oxidation processes. In the oxidation processes. So we have a lot of antioxidants. Mainly, we can classify them into two type. Number one, natural antioxidants. Natural. One of them is ascorbic acid. A good one is ascorbic acid. You must be knowing. Formic acid. And second one is that is a natural one, which is also called, remember, this is called vitamin C. Okay, vitamin C, this is, which source you can get vitamin C. Okay. Second one include, you have different types of molecules. One is uh, B, BHT and BHA. BHA and BHT. Okay. Now the structures, BHA is butylated hydroxyanisole, butyl, OH, OCH3. This is BHA, butylated hydroxyanisole. Okay, and then this is 2-tertiary butyl, and also this compound, OH, this, and OCH3 here. So it's actually a mixture of these two, what is called BHA, butylated hydroxyanisole. Another compound is butyl hydroxytoluene. Here is that molecule. See here, OH, and here CH3. So this is butylated hydroxytoluene, BHT. These are the two compounds which are generally used in 0.02% concentration. 0.02% concentration. Okay. Now they will generate hydrogen radical to trap the oxygen. What they do is they generate hydrogen radical to trap the oxygen. Now, which is the hydrogen radical? See, this hydrogen will be converted into a radical. And the resulting radical is stabilized. That's why it is getting, okay. So it is used in many food products. It is used in many food products like margarine, used in margarine, bread, cheese, very commonly used, butter, then snack food, bakery items. You make any commercial product, bakery cake, then chewing gums. Okay, so all these, so these are the antioxidants. Okay, we'll discuss the remaining part, that is flavor enhancers, etc., in our next video. Okay, thank you.